All right. Good morning, good afternoon, or good evening, everyone. We are back this week with instead of a surface level analysis of a lot of the scientific, we could say, literature that's been coming out, whether it's in articles, whether it's in academic papers pertaining to some type of shift. I don't want to be overly vague on purpose, but some type of perhaps paradigm shift. And so Riel and I are back this week. We will be doing another Kraken this week, but we will be covering the scientific not surface level, but very, very molecular level of what seems to be a lot of analogous and correlative attributes that, when compiled in a particular manner, can be observed, whether it's to the average person or to someone far more advanced in their studies of this in their free time or in academia, can be observed in a way that makes someone sit back and say, okay, this makes more sense than the way it was initially being presented. So without further ado, Riel, how you doing today? And let's jump right into it.
Ooh, I am doing fantastic. I'm super excited for this episode. And as Dave said, we're basically going to be doing an advanced scientific Kraken episode. And we're essentially looking at the latest stories to help us understand that seems there is, without a doubt, a paradigm shift in mainstream academia and with the mainstream scientific articles that we're going to be looking at today. So, yeah, without further ado, Dave, you can start us off with this one.
Sure. Well, according to ctvnews.ca, a 100-year-old color perception theory had a math mistake. If we scroll down a little bit, we'll see here that the 3D mathematical model created by Nobel Prize-winning physicist Erwin Schrödinger, along with other researchers, and used for more than 100 years to describe how our eyes distinguish colors, have been found to have an important math error. Now, the finding was published in the Journal of the Proceedings of the National Academy of Sciences on April 29th, following a study conducted at the US-based Los Alamos National Laboratory that looked into the mathematics of color perception. I'm going to be very blunt right over here when I say that, okay, we have, of course, Schrodinger equation, Schrodinger's cat, all of that. I may seem conspiratorial to some, I may not to others, but for those that really want to get my take, for me, it's very simple. What sticks out to me, Los Alamos National Labs, Mr. Schrodinger himself, give or take, going back to 100 years ago. Again, if we look at the literature and we look at the history from the mid 1800s up until, say, just before World War One, we noticed a solidification in the control aspect of academia. And because at the time there were only, you could literally count on maybe a couple pairs of hands, or at most a few pairs of hands, in terms of how many electrical engineers there were in the world at the time, which at the time did in fact have the electrical engineers at the time had the knowledge and expertise level of what electricians currently have, as I understand it. I could be wrong, but when I look at this, I can't help but think this was a deliberate butchering many decades ago to cover for something that was, at the time at least, for the foreseeable future, seemingly looking to be hid from the masses in general. When I look at something like this is how I see an attempt to, dare I say, rewrite history. Now, that's not a good thing, that's not a bad thing. I'm not trying to get emotion involved, but when I look at something like this is how, for me, I view the way in which the perception of colors, the understanding of the way in which photons and now phonon oscillations create some type of different, we could say, form of experience, shall I say. Some will call it paranormal, some will call it the phenomenon, you name it, will create a different experience in ways that can all of a sudden, oh so coincidentally, now be scientifically substantiated on, at least at the most fundamental level. So one final thing I'd like to say when I look at this is that I'm still quite skeptical as it pertains to the overall objective with this type of dissemination, because I am of the humble opinion that we've seen the suturing of the application-based models that have enabled quantum technology far prior to when we had initially thought quantum computing and all of that was going to be emerging into the consumer and commercial enterprises. Deliberately, there was a deliberate butchering of the theoretical models so that the average person or the average mathematician or physicist could not make the correlation relative to what has been right in front of our faces in our computers and our TV screens, you name it. So I see here a little bit of a few different things: an attempt to rewrite history, an attempt to, again, enter the realm of the quantum paradigm. Specifically, if for those that are on the Patreon, we actually talked about this a couple months back, particularly the paragraph, and I'll quote before finishing here. This is because people perceive large color differences as smaller than the total difference obtained by adding up little color differences between two hues separate from one another, the study's researcher said, concluding that, quote, Riemannian geometry cannot account for this effect, end quote. We see, of course, Riemannian geometry having its correlations to, of course, elliptic geometry, hyperbolic geometry, which is non-Euclidean, which is not straight, which gives the, correlation or potential observation or hypothesis that the concept of string theory being on its way out, maybe it was never really in. I mean, we have to consider that maybe a string is perhaps maybe a comprised set of coils, perhaps, or rings that are put together in such a condensed way that it turns out it appears to be a string at this medium or this level. But when zoomed in, again, at the oh so convenient quantum dot level or nano level, it's something different. So forgive me for the rambling, but that's what I see when I look at something like this specifically.
I think the audience is only grateful for your rambles, Dave. That's
I
excellent.
appreciate. And look,
Awesome.
one last thing I will say is that let's not be naive to all the alleged. To be fair, rumors, not confirmed, but rumors behind Los Alamos National Laboratory. So
Absolutely. Yeah, that's this article definitely stuck out to me, but we got quite a few today that are going to be fairly eye-popping in the terms of like how we're at clearly seeing the advances of like almost like the veil is being lifted and almost as if that deliberate like wrong ideas are now kind of we're recognizing that there were those mistakes. So on to the next one. Magnetic quantum material provides platform for probing next generation information technology. And this is by Oak Ridge National Laboratory, August 16th, 2022. Scientists at the Department of Energy's Oak Ridge National Laboratory used neutron scattering to determine whether a specific material's atomic structure could host a novel state of matter called a spiral spin liquid. The team discovered the first 2D system to host a spiral spin liquid by tracking tiny magnetic moments known as spins on the honeycomb lattice of a layered iron trichloride magnet. Dave, do you have any thoughts about the concept
uh,
of spins and Department of Energy?
well, first, let me say that going back to last week's episode on the surface level analysis of this, so we could arguably call this part two, if you will, but we see we see the funding coming from the National Science Foundation, the Thomas and Betty Moore Foundation. We see it coming from the Department of Energy. We see Y12, Oak Ridge National Labs. Let's also not be naive to the fact that, if I'm not mistaken, think of Mr. Elizondo as you see fit, respectively. But when Mr. Lou Elizondo laid out a map in terms of what he wanted an open database to be comprising of relative to scientific, we could say, conjectures and studies, it all had to do with the Department of Energy laboratory. So that also goes back to the Atomic Energy Commission and the alleged scuttling between the post World War II and the official founding of the Department of Energy in 1977. What occurred within those 3 decades? Did the quote unquote fine gentlemen of the Atomic Energy Commission get buddy buddy with private contractors, private aerospace more specifically? But when I delve in and I see this concept of quantum spin and all of this, the honeycomb lattice and all of this, we have to keep in mind that a lattice essentially speaks to the concept of very tightly confined, if I'm not mistaken, particles, sort of like a mesh net or something like this. These are the particles tightly confined together, which we can see as well is viewed at a quantum level. If you look at some of the academic literature and papers pertaining to this, there were papers written on this. I mean, dare I say, even as far back as the 1800s. So to state that, again, the use of the word quantum, in my opinion, is so deliberately vague on purpose. But one thing that we see here that stands out to me is the spin, the concept of spinning, this idea that, again, going back to the idea of there being rings comprising that of miniature rings that comprise at a larger superstructure level, that of what we interpret and depict visually, photonically, phononically, as a straight line, if you will. Now, when I look, for example, at this and I see the different forms of experiments that have been done using, magnetism, 2D graphene, and different forms of, we could say, if we scroll up a little bit more here, materials hosting spiral spin liquid. When I think of liquid, I must say, Immediately I jump back to the experiments that the Nazis conducted with the Hanabu, with the Der Glocken, Die Glocken, if I'm not butchering the pronunciation. So when I see all of this, I see a direct correlation within that of academia, within that of Operation Paperclip, to the point where they were taking, literally, the Americans at the time were taking the Germans off the shores of Nuremberg in real time. So again, I see a lot of that occurring at around the same time, and so it makes me think quite avidly about the interesting correlations, as if this was muddied, and then later on attempted to be restructured in a manner that is now disseminating to the public. As for better or worse, I don't know yet, to be quite honest. So that's my take on this.
Yeah, absolutely. Like we've got the same players always involved with it, whether it's propulsion laboratories, Department of Energy, etc. Um, there are some interesting things that I wanted to just like we could do a deep dive on every single one of these articles. They could be their own episodes, but we're trying to create kind of a macroscopic perspective of this shift that's happening in academia and the science world. And so one thing, well, a couple things from this article for me is that the finding provides a test bed for future studies of physics phenomena that may drive next generation information technologies. These include fractons and skyrmions. Fractons are collective quantized vibrations that may prove a promising in quantum computing. Skyrmions are novel magnetic spin textures that could advance high density data storage. And so this goes back to our interview recently with Dan Winter, where I was able to ask, so does this breakthrough in understanding gravity mean that we need to kind of reassess our whole perspective on Newtonian physics? And it seemed like the answer was yes, we need to kind of, that Newtonian physics doesn't really talk about spin. But here we have, we're focusing on spin and these new quantum physics breakthroughs. So yeah, like we said, there's a lot to get into with all of these. And another thing to bring up here is the classic Einstein with in quantum materials, electron spins can behave collectively and exotically. If one spin moves, all react. An entangled state Einstein called spooky action at a distance. The system stays in a state of frustration, a liquid that preserves disorder because electron spins constantly change direction, forcing other entangled electrons to fluctuate in response.
For anyone that's interested in the theoretical side, take a look at the Pauli exclusion principle, and you'll find that will may lead you down a path for those interested.
Right on, Pauli exclusion principle. Okay, I'll take note of that. But yeah, here, on to the next one, Dave.
All right, so according to phys.org, creating a chiral polymer from achiral monomers using a magnetic field. So a combined team of researchers from the Weizmann Institute and the Israel Institute of Technology, both in Israel, has developed a way to create a chiral polymer from achiral monomers using a magnetic field as a way to align the spin of the electrons that are involved in bond formation. In their paper published in the journal Science Advances, the group describes their technique and possible uses for it in spintronics. Now, I want to point out, in my humble perspective, the one thing that is not being told is that everything is comprised of spin. When people say, Dave, what do you mean by spin? Literally think of a circle spinning. Now think of one circle spinning and then another circle spinning the opposite way. And when those spins in a particular regard kiss, if you will, as Mr. Dan Winter speaks on with the pine cones kissing and what have you, interesting things may occur. And so that's what again, we see here a fractalized version at the molecular level that also speaks to the potential hydrogen bonds that this spin may effectuate in this regard. Now, what's quite interesting here is that we see that the work by the team involved placing a monomer molecule on an electrode and altering the direction of the flow of the current beneath it as a means of controlling the magnetic field on the electrode surface as additional monomers were added. Doing so allowed for spin polarized electrons to be controlled as they were absorbed up into the body of the molecule, and that allowed for manipulating the shape of the polymer as it grew. The result was a chiral polymer with a desired shape. Now, if we scroll up once more, to look at the images very quickly, there we go. I can't help but think, particularly figure A, both figures A actually, and both figures B, if there's a form of alignment in this regard, this speaks to what's called angular momentum in quantum field theory, and the residing of the angular momentum, as we've seen, for example, Ling and Tor comment on in a particular paper from the 90s. The If I'm paraphrasing here, but the possibility for angular momentum in superconductivity resides in that of the lattice ions, not the Cooper pairs, but in the lattice ions, which speaks to the concept of a hooking in, if you will, with half integer spins regarding the Pauli exclusion principle of the electron spin rate. So what we see there is ultimately a much more micro version or nano version of this overall, we could say, propagation of spin that at different rates, spun at different rates with different magnetic fields applied to it, allow for dare I say, coercion or manipulation. I don't mean that in a positive nor negative manner, to in fact be adjusted to whatever the one behind the tool is using it for. Again, of course, comprising that of the DNA double helix as well. So that's my take right there.
Right on. And Dave, you have been doing your homework. I hope that people appreciate that this is more of an advanced scientific analysis and not just the surface level. And yeah, obviously for me, I see this shape as the heliacal toroidal shape that we've been learning is pretty much the way that biological life is formed.
If I
So,
also may
yep.
say one last time too, the lattice the electron holes that reside within the couplings within the lattice ions are so strong that they actually rock a little bit within the nucleus because of how strong their potentials are, not their current power, but the potential for it to have that magnitude of power. So that's just something I wanted to point out very quickly. For those that know the back end of that may be telling.
Well, some of the stuff you're talking about, just for the audience's record, is going over my head. So I have some studying to do for sure. But that's why we've got Dave here to give us these breakdowns and analyses of what's going on in the scientific world. So on to the next article we've got. Not accurate enough. Scientists remeasure the gravitational constant. Whoa, this is from August 17th. So this is pretty recent. And if you just look at the image, I mean, if you're listening to it at home, definitely recommend, we'll share the articles so you can look at it yourself, but look at these fractal shapes in that image. But the gravitational constant G determines the intensity of gravity, the force that pulls the Earth in its orbit around the sun or causes apples to fall to the ground. Okay, well, let's just stop right there. Because as Dan Winter just explained to Generation Z and Dan Winter's audience as well, scientists don't actually understand how objects fall to the ground. And so we're going to include that. We've got this link here that we're going to include as well from Dan Winter explaining why objects fall to the ground, the origin of centripetal force. Is this article going to talk anything about the origin of centripetal force? I don't believe it does. The value of G has been the subject of several tests throughout the years, but the scientific community remains unsatisfied with the result. In comparison to the values of all the other important natural constants, such as the speed of light in a vacuum, it is far less accurate. Okay, well, so yeah, Dave, what stands out to you when they talk about the...
What do they say here? Gravity is a force. Could you scroll down a little more if that's
Yeah.
all right?
Yeah.
Right there.
Okay.
A little more up, right above the picture.
Oh, gotcha.
Perfect.
Okay.
Thank you. Gravity is a very weak force that cannot be separated, which makes it incredibly challenging to measure. I would very strongly disagree with that. That right off the bat, the only quote, the only option for resolving this situation is to measure the gravitational constant with as many different methods as possible. I would like to know which methods the funding that gave the Department of Mechanical and Process Engineering at ETH Zurich had allowed for relative to this experiment, because, I mean, you know, I'm going to be honest with you.
They've got it right here. So Duel's team set up their measurements equipment at the former Fergal's Fortress, which is located close to Pfeffers above Bad Bragaz, Switzerland, in order to exclude sources of interference as much as possible. Two beams hung in vacuum chambers make up the experimental setup. After the researchers set one vibrating, gravitational coupling caused the second beam to also exhibit minimal movement in the picometer range, i.e. 1/1,000,000th of a meter. Oops. Just getting a call.
See,
The
now
researchers
this is
used laser equipment to measure the motion of the two beams. But yeah, what are your thoughts on that?
I Now, let me be clear to the audience. I'm not a scientist whatsoever. I don't particularly think the value the researchers arrived at using this method is 2.2% higher than the current official value given by the Committee on Data for Science and Technology. If they're looking to attempt to improve, what is this? Planck's constant, was it? Or was it
The gravitational constant.
gravitation, excuse me, gravitational constant? If they're looking to improve just the measurability of the gravitational constant, in my humble perspective, this will do it, but it'll get you closer to more accurate results relative to more accuracy pertaining to a mathematical predictable model or scale. Particularly when you talk about like things, for example, symmetrical regauging or symmetrical gauging of vector states, or opposing vectors, or particularly in quantum field theory. But with respects to understanding what makes up gravity, I don't think this will bring us any closer. But if the simple attempt was to just get a more concise measurement, then sure, that's. But I'll
They even say right here, science has still not fully understood this natural force or the experiments that relate to it. So they straight up are saying we still don't know why gravity occurs, and yet we have our friend of the show, Dan Winter, explaining why gravity occurs. So and just in addition to this, I don't know if you've looked at Maurice Cotterell's work, but he was somebody that Dan Winter referenced. So I was studying his webpage and some of the articles that he's published. And so not only does he talk about how to make free hydrogen, but he also explains why all bodies fall to Earth at the same acceleration and speed, as well as he provides an anecdote about him trying to get his studies published, sending it to physics journals, and they say, your work is original and we don't publish original work, because he's got a whole new perspective on why gravity occurs. So it's just this
to the
this
control
right here
system.
is very interesting.
Right. This speaks to the control system in which we spoke on last week's episode pertaining to this, with respects to if the quote unquote convenient rules of the system within the system, particularly in academia and STEM, do not prevent one from publishing such ideas that certain people within STEM don't want published. They just
Yes.
simply knock you down. They just go down.
Exactly, exactly. But so Maurice Cotterell is somebody that I'm going to be looking more into in our own research here. But I think that we can move on to the next one. And this one is for you, Dave.
We see here, according to ScienceDaily.com, biologists track DNA parasites in the hunt for disease treatment. Study uncovers key insights into little understood phenomenon. This is based out of the University of California in Irvine. We see that they are considered parasitic genes, even though they comprise over half of human DNA. Much remains to be learned about them. Now, University of California Irvine biologists offer new insights into these entities known as transposons, providing knowledge that could one day help in the fight against cancers and aging-related diseases. Unlike genes that encode proteins needed for us to function, transposons make proteins solely to copy their own DNA and insert it into other elements. They are selfish parasites, said study leader Grace Yu Chuen Lee, assistant professor of ecology and evolutionary biology. Quote, they perpetuate themselves, and most of the time they don't do anything for us, end quote. Now, to the extent in which one could say, could this be in a medical sense or scientific sense, even epigenetically or biologically, quote unquote, manipulated, I use that word carefully, in a way that could help serve the human body better, sure. But then we must ask ourselves, to what extent does the human body allow or not allow for these types of cells to be activated or deactivated relative to the epigenetic environment and context of certain variables that are not privy to the public domain of academia, to then allow for this research to continue on. And what I mean by that essentially is, I'm not trying to downplay those that are doing this research with respects to delving into extreme and complex fields of study. Because I do not mean to take away from these scientists' hard work, but rather, dare I say, I'm of the humble perspective, a lot of this could in fact be understood if there was not so much of a deliberate suppression and oppression, give or take 120, 150 years ago, within the financial control aspect of things. Now, we see, by the way, that the funding that comes down from these universities, for example, of California and all of that, the funding comes down with packages from the National Science Foundation and others that already tell you the models in theory that you're going to use to then translate into the laboratory for proof of concept applications. if any of these scientists were to go out of their way and say, we want to try a different model, or we want to try a different form of a model to then suture into the application-based laboratory setting, you're just not going to get any funding ever again. So this speaks to the idea that these scientists are doing truly, genuinely the best work that they can, the ones that are not quote unquote in the know, if you will, but they're doing the best work they can without even realizing they got one arm tied behind their back, so to speak. So ultimately, I would dare to say that what I'm trying to get at is this could be far more understood, in my humble opinion, if certain aspects of the scientific enterprise were in fact divulged to the public domain. Now, that's a separate conversation as to the ethics of it and what have you, but I think that this could be easily understood and, or dare I say, resolved and perhaps even put to good use in an organic sense for healing and what have you, and for treatments if the scientific community was not largely working with one hand tied behind its back.
I totally agree with you, Dave. And I wanted to add that this article stood out to me because of this is going to be a little more woo woo, but the concept of these fourth dimensional parasites that potentially could be like the genetic farmers of this terrarium that we live in. And this is part of the drop feeding disclosure of as these negative entities are apparently being kicked out, they still have some remains in them. But it's almost as if like now that we've kind of almost like conquered these higher conscious beings that have been suppressing us frequently in other means. Now science is like, oh, and it turns out that yeah, there's some science that actually supports the idea that there are like parasitic aspects of that stuff that's dripping into mainstream science, especially in our genes. The idea that
This
genes
could
can be
also
turned
be,
off and turned on.
to your point, this could also be simply a scientific, we could say, an artifact of the literature to back up any potential quote unquote phenomenons that occur in the
Hmm.
future.
What did you say? An artifact, a scientific artifact?
An art, meaning basically they can point back to this to say, well,
Ah,
we've covered this in the literature for those that may be skeptical if something occurs relative to any of these parasites down the road.
right, right. Awesome. Now this one was I was super I've been sitting on this one well ever since it came out because this is very exciting based on the research that I've seen Dave do on the channel, especially when you started bringing up one of these words here, a new connection between topology and quantum entanglement. Theoretical work reveals an unexpected link between two major principles in physics that may inform future experimentation and an understanding of how to harness quantum information. Dave, I think that this this
Well,
should be
if
all
we go
you.
back to not last week, but I think a few weeks ago, we talked about this idea on one of the Krakens of, say, for example, everything we observe, experience, touch, all of that is like a stack of books, and the top stack, the book at the very top is all that we experience in a particular fashion relative to our senses, the way we think, and all of that. But there are books underneath that book, and there's an unlimited amount of those books that you can pull from that stack. But in order to pull from the stack, you need to remove the top one to get to the next one, and so on and so forth. Well, the idea would be that the stack of books, other than the one at the very top, resides in what's called the vacuum, if you will, or the foam of the vacuum, or the quantum foam, or you name it. Now, there are different postulations and theories about the vacuum, what comprises the vacuum, all this and that. But ultimately, we see here that according to ScienceDaily.com, and I quote, our work ties two big ideas together. It's a conceptual link between topology, which is a way of characterizing the universal features that quantum states have, and entanglement, which is a way in which quantum states can exhibit non-local correlations. And that would be a spooky action at a distance, as Einstein said, where something that happens in one point in space is correlated with something that happens in another point in space. What we found is a situation where those concepts are tightly intertwined. So again, this idea of non-locality, something occurs one place, there's an opposing occurrence of that, we could say, initial action elsewhere within the confines of this reality we're in, which speaks to the Pauli exclusion principle. So when I look at this, essentially they're saying that, say for example, I take a sip of my coffee right now and say there was a second Dave. In this reality, there would be the other Dave taking another sip of this coffee in perhaps in an opposing and opposite way on the other side of the planet. It really depends with respects to what we're speaking in the context of. But we see here that, and I quote, A classic way of thinking about topological surfaces, says Kane, is to consider the difference between a donut and a sphere. What's the difference? A single hole. Topology considers these generalizable properties of a surface which are not changed by deformation. Under this principle, a coffee cup and a donut would have the same topological properties, right? So we consider the Fermi surface of copper as a topological object, then the associated number of holes it possesses is 4, a figure also known as a genus. Once Kane began thinking of the Fermi surface in this way, he wondered whether a relationship could exist between the genus or genus and quantum entanglement. So again, what I see here, I'm going to be very blunt. Behind the scenes, they know exactly what they're doing.
It's like they finally stopped being so compartmentalized, and it's like finally like they've just everybody's had a wall. They're all in their own little cubicle. But to me, it's like all of a sudden now the whole industry of topology and quantum entanglement now suddenly, oh, you guys can talk to each other and figure out, oh, they're connected. This is so good.
Well, and not only that, but at the same time, a lot of them are allowed to come out with their findings, their publishings, you name it. But notice as well too, they stop just short of explaining precisely the core source of that phenomenology. Where is the what differentiates this topological formation of a you could say vector scalar toroid from that of a linear, we could say more Newtonian based um, format. So that's another thing that they won't explain in that regard. So
And just for those that are curious, here I just on Wikipedia, genus in mathematics, a genus 2 surface. This is a visual of the coffee cup becoming a donut, how it's the same surface in topology. And then here you have a genus 0, 1, 2, 3. And to me, at genus 3, this actually looks like one of those fidget spinners, or in a way, a TR3B. So it's interesting how we've got these things that are just a part of like everyday life in our subconscious, but actually it's very advanced mathematical terms. But I do find it very interesting that these are coming out at this time. So right on. Okay, Dave, this is yours.
So according to phys.org, exploring quantum electron highways with laser light, topological insulators or TIs have two faces. Electrons flow freely along their surface edges like cars on a superhighway, but can't flow through the interior of the material at all. It takes a special set of conditions to create this unique quantum state, part electrical conductor, part insulator, which researchers, hope to someday exploit for things like spintronics, quantum computing, and quantum sensing. For now, they're just trying to understand what makes topological insulators tick. Now,
and there's a lot of spintronics and spinners in these scientific articles in the past August. What's with this breakthrough?
This goes back to the lattice, to the angular momentum having to. This goes back to the overall concept of angular momentum propagation that via, as you know, many have talked about phase conjugation, which is basically when you take at angstrom level measurement, when you take two pairs of lasers and point them directly at each other, you notice what then becomes not so much a line, but then turns into some type of angle. And then that angle turns more so into a curve. And next thing you know, you have, for example, the translucent crystal, as we see here in this photo. In addition to that, of the pine cones kissing, as it's been so often coined and discussed, but in addition to the DNA double helix, which goes right back to spin, because those wavelengths of the DNA double helix are opposing in a curve-like manner, that then when you trace the outline, create, we could say, two spinner rings opposing, that again speak to two spinners kissing, and those spinners kissing are within a confined outline that just so happens to make up a triangle. So you have your platonic solids constantly being toyed around with, if you will. You have your sphere, your square, your your circle, your square, your triangle. And we see those, by the way, in this image here. Now, when we look at the money side of it, we see here that, and I quote, in the latest advance along those lines, researchers at, again, the Department of Energy, the SLAC National Laboratory, and Stanford University systematically probed the phase transition in which a topological insulator loses its quantum properties and becomes just another ordinary insulator. They did this by using spiral beams of laser light to generate harmonics, much like the vibrations of a plucked guitar string from the material they were examining. Now, for those on the Patreon, you'll know we've covered this many months ago. We see, again, those harmonics make it easy to distinguish what's happening in the superhighway layer from what's happening in the interior, and see how one state gives way to the other. They reported in Nature Photonics today. The harmonics generated by the material amplify the effects we want to measure, that making this a very sensitive way to see what's going on in a topological insulator, said Christian Hyde, a postdoctoral researcher with the Stanford Pulse Institute at SLAC, who led the experiments. And since this light-based approach can be done in a lab with tabletop equipment, it makes exploring these materials easier and more accessible than some previous methods. Now, we'll see here in the image, we have the 3D topological insulator, we have high order harmonics, and we have circularly polarized lasers. Now, again, this goes back to the concept of spin. So the concept of spin harmonics, which also takes us right back to why I prefer the term consensus harmonics instead of consensus reality, relative to that of, again, reality is only as real as the individual observing it, so to speak, within the confined local state that one is viewing it in. So when I see here that they're talking about, notice, what are they using here? They're using light and sound. As a matter of fact, the 3D topological insulator they're using, the table they're using for that experiment is comprised of extremely fast oscillations of both harmonics and photons and phonons and all of that. So the stuff they're experimenting on to observe is comprising the same material they're using for that experiment. So in other words, is this a correct path into understanding much more of what we could say comprises this? Sure, because we see here a linearly polarized light is far more elongated in its waves compared to that of a circularly polarized light, which is much more coil based. Now, I'm going to be
Are they making it longitudinal then instead of transverse? Are we seeing that transition right there? Is like,
there, I would say it depends in the ways they want to propagate it relative to this particular experiment. I don't know. I'd have to
Okay.
see the actual experiment myself. I could be wrong, but we
Right.
see that laser light is usually linearly polarized, meaning that its waves oscillate in only one direction, up and down. Now, if again you were to put another beam at it, and then you have that cross section, or that we could say that interference, if you will, with those beams, you then have a little bit of a different emission coming, which then leads to a different result in the overall experiment. So we see that this could be, quote unquote, manipulated, if you will. So we see that first they took their samples to SLAC's Stanford synchrotron radiation light source for examination with an X-ray technique called angle resolved photoemission spectroscopy, or ARPS. This allowed them to narrow down the general neighborhood where the transition takes place. So again, they were able to focus in more on the source of this. But now let's go back to the concept of the money and the control system. They needed that facility to confirm this. And who owns, funds, runs the facility? I mean, we could all trace it back to Department of Energy, the overall apparatus of STEM within the North American conduit. So,
And how all of the like mainstream academic institutions are going to have the same recurring ones over and over again, where they have the labs. It's their scientists, their
yes,
professors that are
right,
doing all of it, who are on the payroll, who
right,
probably have NDAs and probably have, just compartmentalized information, potentially higher access to information. Who knows if it's
precisely.
classified and all that. But yeah, right on. Like these are, again, like every one of these articles, man, could be its own deep
Oh,
dive.
sure.
But
Oh, yeah.
this is, yeah, good job, good job. So next up, scientists open new frontier in quantum science and technology. Okay, like we could have opened with this one because that's kind of the segue, but researchers have opened a new frontier in quantum science and technology by using photons and electron spin qubits to control nuclear spins in a two-dimensional material. This will enable applications like atomic scale nuclear magnetic resonance spectroscopy and the ability to read and write quantum information with nuclear spins in 2D materials. Again, these spins, everything is spinning. It's like they've all recognized and have agreed, okay, we realize that Newtonian physics doesn't talk about spin or rotation, so let's all of a sudden start blasting this to
Well,
everybody. Like,
notice to your point as well how they'll never talk about what's behind. And when I mean they, I mean the whole media complex, even particularly the academic, in this case, complex or structure. They won't talk about what they're doing to enable that quantum, we could say, result, if you will. The quantum technology depends, we see here on the qubit, which means is short for quantum bit, which is the quantum version of a classical computer bit. Okay, and what's that? You see, they won't go that deep.
well, quantum, according just to a quick search here, is the smallest amount of a physical quantity that can exist independently, especially a discrete quantity of electromagnetic radiation, or it's the amount of energy regarded as a unit, or it's a quantity or amount. So the way that they throw around quantum everywhere to really make it seem so fascinating makes it seem more like they're just focusing on the Q letter than like
Well,
any of these words could be this thing that they're just throwing around as a buzzword.
that too, but we see as well that the smallest, if you could jump back
Oh
really
yeah.
quickly, the smallest amount of a physical quantity that can exist independently, especially a discrete quantity of electromagnetic radiation. Again, see, to your point, what are they doing and what have they understood both on the theoretical side and what have they brought into the application based side, even if it's just for private research at a classified level, to enable that understanding? What has brought that next level of, again, that smallest amount of a physical quantity? Is it just better, we could say better, uh what's the word? Wow, I'm drawing a brain fart to zoom into stuff really closely.
The microcosm, micro scale.
Micro, right? Yes, precisely. Is it that just the technology on the applications based side has gotten better? Because we see as well the smallest amount of a physical quantity that can exist independently, especially a discrete quantity of electromagnetic radiation. Okay, so that's what quantum means. All right. What tools are being used to measure that? What models are being used in the literature to confirm this? And what conjectures or theories are closer to that confirmation? And why is that the case? I'm not trying to be a smartass. I'm just trying to help the audience understand. They're throwing around the word quantum a lot, but it's the minimum amount of any physical entity involved. Now, how do, again, this speaks to the concept of we're going to introduce quantum to the world, but just don't worry about what comprises it. Just stop there.
Mm.
You see what I'm saying? So that's where my mind goes.
Sure, yeah, it's like always they're telling you it's not quite like that BS sandwich that you talk about, but it's like they offer a little bit like a lot of the truth, but they're excluding a very important part to really help you understand what they're actually talking about.
Quite a few different parts, I would say, in my opinion. Yeah.
Hmm. Yeah, and I mean, so this article again is talking about the spin, and this is, we could obviously get deep into it, but we're just trying to like paint a picture of like how there is this clear shift in mainstream academia that we could argue is being allowed or pushed from the folks that are funding these operations that really know about what's been going on and have known for a very long time, and all of a sudden the dam has broken, and they're like, "Hey, let the information out. We've just got to get it out there," whether they're being forced to, as Davis said, with there being a potential timeline or higher conscious beings that are really pulling the strings behind the scenes that are saying with the kids are ready to see the advanced stuff. But yeah, and like, do you have anything else to add on that one, or do you want to move on? Okay, right on. So the next one, meet Xiaomi's new humanoid robot, Cyber One, from TechCrunch. So long gone are the days when a consumer electronics company could simply announce a phone and call it a day. At this morning's big launch event in Beijing, Xiaomi followed up its foldable news by handing the stage over to Cyber One. The bipedal humanoid robot joined Lei Jun on stage, greeting the CEO and handing him a long stem flower. So this is just another, well, I don't know if it's just another, but the Lei Jun was quick to flex the company's investment in the category, noting Cyber One's AI and mechanical capabilities are all self-developed by Xiaomi Robotics Lab. We have invested heavily in R&D, research and development, spanning various areas, including software, hardware, and algorithms innovation. So it's just talking about how extremely advanced this robot is, and it's like we're fine, like, and this is a big event. So the some things that this robot can do. This humanoid robots rely on vision to process their surroundings, equipped with a self-developed MiSense depth vision module and combined with an AI interaction algorithm. Cyber One is capable of perceiving 3D space as well as recognizing individuals, gestures, and expressions, allowing it to not only see but to process its environment. In order to communicate with the world, Cyber One is equipped with a self-developed MEAI environmental semantics recognition engine and a AI vocal emotion identification engine, enabling it to recognize 85 types of environmental sounds and 45 classifications of human emotion. It's like, okay, we're not getting into the science of this, but like, here's a pretty big breakthrough that they're like, yep, throw it into the world. We're going to tell them what's really going on behind the scenes. And here's a bit of some, like, an introduction to it.
I would say if the science was not held back with respects to suppression and oppression and all of that, this is something that would have been introduced shortly after World War II, if I'm being very honest with you. And I
Yes.
don't say that to disrespect the ones that have put in the hard work on the surface that would not be privy to such alleged, we could say, cover-ups and what have you. Not saying that is the case in this particular context, but when to me, when I look at this, I see, for example, okay, the way that the robot is detecting the different alterations in mood and behavior and all of this, clearly it's detecting the different, we could say, variations and fluctuations of different we could say, oscillations in the body, whether vibrationally or otherwise, whether chemically, you name it. So this is something that, if again, we have to consider that we don't necessarily need a human looking robot to have things detect this in us. Could this already be in our phones? And I don't say this to fearmonger. I say this for the sake of just, neutral thinking, if you will. So that's where I stand in that. I mean, ultimately, with respects to if from a moral or ethical standpoint, if people would like a robot as an assistant or something like this, I genuinely, truly do believe that comes down to you as an individual. I don't necessarily want to sit here and say, well, you should or you shouldn't or this or that. Just like everything else in life, moderation, balance, the concept of duality and polarity, it ultimately also comes down to, in my opinion, who is behind the curation and suturing and control of said tool. In this case would be the human robot. A tool has no emotion. Now, if a tool was developed using some type of manipulated electromagnetic or phenomenological, yet to be understood quantum, whatever, gibberish you want to call it, that's a little bit of a different conversation. But that's where my mind goes for this.
Right on. Totally. That's very well said, Dave. Okay. For you here.
So, according to SciTech Daily, Harvard researchers have linked spirituality to healthier lives and longer lifespans. If we scroll down a little bit more here, we'll see that, according to a study conducted by experts from Harvard and Brigham and Women's Hospital, spirituality should be incorporated into care for both severe disease and general health. Now, again, I would fully agree with this, but I also find, quite interestingly enough, particularly for those that are on the Patreon, you'll see that we talk about this concept that the overall control apparatus of any industry, or dare I say every industry or most, ensures or does their best to ensure that the average person participating within the whether the consumer or academic enterprise of said industry does not exceed that of wanting to learn more than the limits that have been set by the quote unquote you could say overseers or elites of that enterprise, nor do they want the average person to look into anything too specific. So you go too big, you go too macro, they don't like it. You go too micro, they don't like it. They want you in the middle of saying to yourself, yeah, sure, spirituality is great. The question becomes, to what extent is that curated, controlled, derived, disseminated? That's where my mind goes here, because we can throw around spirituality, quantum. At the end of the day, it's a label that we use to interpret for ourselves in order to neurologically give meaning that we then decipher and interpret differently in our own minds. So that's where I go here in this particular case.
Totally. And I would like to add that it's refreshing to honestly see that at the Harvard institution, they're quoted as saying, focusing on spirituality and healthcare means caring for the whole person, not just their disease. And to me, the timing of this is actually brilliant, because for the Kraken that we'll be doing in the next couple of days, there's a lot of focus on the healthcare systems all around the world that are completely deteriorating. So to have like revamping the whole healthcare system with some more spirituality in it, I think is very good. So let's see, Dave, what do we have next lined up? So here, we'll do this one. We've got like 2 or 3 more stories, and then we'll be wrapped up for the day. But we're going to continue these actual scientific breakdowns because there's so much to be going through.
Right. So we see here, according to SciTechDaily.com, this headline reads, Earth's magnetic poles are not likely to flip. Again, just written a handful of days ago as of the day we're recording this. We see here that there has been a speculation that Earth's magnetic polarity is about to reverse as a result of the appearance of a mystery area in the South Atlantic where the geomagnetic field strength is rapidly dropping. The present changes, however, may not be unique, and a reversal may not be imminent after all, according to a recent study that compiles data going back 9,000 years. This study was recently published in the Proceedings of the National Academy of Sciences. And I also want to point out, without taking any jabs at any of these publications, we'll find as well that there's we could say, an interesting set of affairs having to do with a lot of these publications and journals, not particularly pertaining to the individuals running them now, but to the overall history going to back 120, 150 years. So if we scroll down a little bit more, we'll find here that the invisible barrier provided, if we could, there we go, thank you, by the magnetic field of the Earth protects against solar winds in the highly dangerous environment in space. However, the magnetic field is not stable, and polarity reversals occur irregularly, on average once every 200,000 years. In other words, the north and south magnetic poles switch places. Now, again, the Earth's magnetic field has weakened by around 10% during the last 180 years. What's interesting is that when you look at, again, particularly the number 180, again, we take certain integrals of electrons, half integer spins, and what have you, with respects to 180 certain conditions met in certain fields and laboratories and what have you, and you have interesting results. So I call BS on this article. I think that
Yeah, you brought this up last time on the Kraken. It's like, well, actually, just so happened, or on our surface level scientific analysis, and it's like, actually, one of the articles lined up is that they're not likely to flip. Which,
I
yeah,
agree 100%. I mean, I see definitely I think there's going to be an anomaly, a flip of some type, 100%. I think this is something that, again, I'm not trying to discredit the study or take a jab at the study, but I mean, it's all about how data is interpreted. So I think we need more than one study to conclude for something like this.
yeah, absolutely. And I can't help but see just how the magnetic energy is just like the torus, which is like the Earth having its own toroidal field of energy, its own plasma donut, if you will. And they're showing it right here, but without actually explaining, they're just saying, no, it's just magnetism. But they're leaving out a very big part of us understanding what really is going on with all of this. Um, so I think that we're just going to do one more, and then we'll wrap it up for today because we still have so much to cover in future episodes. But this one, this is a two-parter here, is that from Jerusalem Post, August 15th, an asteroid 2.3 times the size of a dinosaur heading for Earth, says NASA. And the asteroid 22PW may be small, but it will fly dangerously close to the Earth, relatively close to the moon's distance to the planet. Okay, so reading this from August 15th, they say that the asteroid in question will pass by on August 16th, 2022. So this already happened. Okay, but it's noted by NASA's Jet Propulsion Laboratory, by the Center for Near Earth Object Studies. Okay, so it's already passed us. Apparently nothing happened. Well, maybe something occurred, but I have not actually checked to see, oh, were there any earthquakes? Were any sort of impacts? But so the interesting thing that I want to bring out here in our kind of scientific analysis is, because I was curious about that, I started to look into, well, Jet Propulsion Laboratory and Center for Near Earth Object Studies. So I found that there is a hypothetical asteroid impact scenario. And this hypothetical impact scenario talks about, so it says, very clearly, this scenario is realistic in many ways. It is completely fictional and does not describe an actual potential asteroid impact. An asteroid is discovered on February 11th, 2020, and in this scenario. And what they say is that, let's see if I can find it. They talk about the date is August 16th, 2022, in their hypothetical scenario for when this asteroid is going to come by the Earth. So as the uncertainty region sweeps past Earth on August 16th, only about 5% of its impact, only about 5% of it impacts our planet. The following image shows the extent of the large region, here shaded in red and purple, where 2022 TTX could potentially impact on August 16th. The region covers roughly 2/3 of the Earth's surface. So this is they're explaining how, based on its trajectory, it could impact the Earth anywhere around here, and it's just showing the highlighted map. But I just found this very interesting that we have the Jerusalem Post reporting August 16th that the near asteroid impact is going to occur. And then we go back to this tabletop exercise, and that's the same date that they chose. And I'm going to draw the parallel to the monkeypox simulation deep dive that we did on the show, where we saw that they had a tabletop simulation exercise where the outbreak of monkeypox occurred the same week, hypothetically, that it actually did in real life.
Kind of like as above, so below. They need to counteract a certain action, if you will. It's interesting.
Yeah, so I mean I feel like that's we can end that on there, even though that's not the super most high-end scientific analysis for that little article. But anyway, Dave, thank you so much for joining me today. This has been a lot of fun, and we've got a lot more articles lined up for us to be reviewing. And your knowledge has you have leveled up so much, and I'm sure that the audience is going to appreciate you sharing all of your insight into the scientific
Well,
world.
I appreciate you being here. I appreciate your compliments. Truly, you've done nothing but improve yourself, and I appreciate everyone that's jumped in and chimed in, whether to listen to this via audio on Spotify or Apple Podcasts, or video on YouTube as well. So thank you so much, everyone, and we'll catch all of you next